Hey guys, Mr. Isley here. So we're on to the final little section of Chapter 3, graphing linear inequalities and deciding if ordered pairs are solutions to them. So as we talked about in the process video, what we're going to do is we're going to go in and graph each line just like we did before in the previous videos, and then we are going to figure out which points fall in the solution areas or on the line if it happens to be a solid line. So again, first thing in order to be able to graph the line that we need is the y-intercept. So we need to identify our y-intercept. And our y-intercept is always found after x. So after x, I see a minus 5 or a negative 5. So our y-intercept, again, is 0, negative 5. So I'm going to go in and graph that point. So 0, negative 5, start at the origin. Don't move left or right, but move down 5. So 1, 2, 3, 4, 5. And there's my first point, my y-intercept. Then I need to use the slope to create my next 2 points, minimum next 2. So the slope, again, is always found in front of the x, so that would be the negative 1/2. Now again, we've talked about let's move that negative to the top, though it's not the only way to do it, it's the way we've been practicing. So really what I have is negative 1 over positive 2. Now remember, we need to know what each number tells us to do. So negative 1, the top numbers always rise or fall. Well, negative means we're going to fall 1, which means the bottom number, which is positive, always tells us to move to the right. So we're going to move to the right 2. So again, I'm going to go back to my y-intercept and do that to create my next 2 points. So from my y-intercept, I'm going to fall 1, move to the right 2. Then I'm going to do it again. Fall 1, move to the right 2. Now again, reminder, you can always do the opposite of both those things. So instead of falling 1, I'm going to rise 1. Instead of moving to the right 2, I'm going to move to the left 2. And that's still going to be a point on the line. Now before we go in and draw the line, as we've talked about, we need to identify, is it a solid or dashed line? And we do that by looking at the inequality symbol itself. And if there is any portion of an equals to sign in the inequality symbol, that means it's a solid line. This one is just a simple less than symbol, so that means that my line is going to end up being dashed. So I'm going to come in here and do my best to line up my points. I want to make sure I'm drawing right through the middle, right? And I want to make sure that I am creating a dashed line. So again, we talked about you could either go in and do a solid line to begin with and then go back and make it dashed. You could also do a dashed line as you go, like you saw me do just now. So once I've got my dashed line, then I need to use a test point to see, all right, which side of the line the solutions lie on, because the dashed line tells me that if the point is on the line, it is not a solution. So I'm going to use a test point of 0, 0, which is the recommended test point. It falls above the line in this case. So I'm going to plug in 0, 0 in for the x and for the y and see if it comes true. So into my original inequality for y goes 0, which is less than negative 1/2 times n for x goes 0, and then minus 5. Now as we've talked about, anything times 0 is still 0, so really this whole thing just cancels, and we're left with 0 is less than negative 5. So once we've got it down to the 2 numbers to compare, we need to decide if that's true. Well, 0 is not less than negative 5, so that is false, which means everything on the side of the line with the test point is false, which means everything on the opposite side is true, and we always shade the true side because that's where the solutions fall. So we know that any points at this moment that fall on this side of the line are going to be solutions. Any points that fall on that side of the line are not going to be solutions. And then because it's a dashed line, we know that any points that fall on the line are also not solutions. So last part of this is we need to check the ordered pairs that they gave us and see if they fall on the line. So the ordered pair of negative 4, 8, I'm going to start at the origin, go left 1, 2, 3, 4, and up 8. That point is right there. That is not in my shaded area, so it is not a solution. The point 2, negative 10, that tells me from the origin, go right 1, 2, down 10. That falls in my shaded region down here, so that is a solution. The point negative 6, negative 5, so again, back to the origin, go left 6, 1, 2, 3, 4, 5, 6, and down 5, 1, 2, 3, 4, 5. So that is again in my shaded region, so that would be a solution. Then we need to check the point 8, 0. That says go right 8 and then don't move up or down. Again, that's not a point in the shaded region, so it is not a solution. And then our last point of negative 2, negative 4, that says go left 1, 2 and down 1, 2, 3, 4. Now that point falls on the line. But because this is a dashed line, points on the line are not solutions. So that means the point negative 2, negative 4 is not a solution to this linear inequality. And that is the process that we go through. So again, in terms of work, obviously you've got to have the line. It needs to be dashed if it's supposed to be dashed, or solid if it's supposed to be solid. The appropriate side shaded. You need to have the work to show your test point and how you arrived at which side to shade, all right? And then obviously cross out the ordered pairs that they give you that are wrong, all right, and are not solutions. Circle the ones that are right. All right, well, let's move on to example B. So if you flip your page over to the very back side of your packet, we've got 2 more examples of these to go through, all right? So I would encourage you to, if you think you're ready, try example B on your own, then check your answer with mine. If you're not quite ready, then work through it with me. So again, our first starting point for graphing these lines is always going to be the y-intercept, right? Which we find after x. Now, when I look at this, I do not see anything listed after x, which again, reminder means that it is the same as adding 0, because adding 0 is the same, so we don't need to write it. It doesn't change anything. So my y-intercept again is 0, 0. So I'm going to graph that point. That's the origin where I start, and so there is my first point on my line. Then I need to find the slope. Well, again, slope is always found in front of the x, so in this case it is the 3/2 right there. So again, we need to know, well, what does the slope tell me to do? Well, top numbers always rise or fall. Because it's a positive 3, I'm going to rise 3. And then the bottom, if it is positive, that tells us to move to the right. So we're going to go right 2. So now we need to get at least 2 more points. So I'm going to do, from the y-intercept, I'm going to go up 1, 2, 3, and then right 1, 2. There's my next point on my line, and then do it again. Up 1, 2, 3, right 1, 2. And there's the next point on the line. Now again, you can always do the opposite of both those things with the slope to still create a point. So if I went back to my y-intercept and I went down 1, 2, 3 instead of rising, and I went to the left 1, 2 instead of to the right 2, I still end up with a point on that line. So either method is fine, all right? This is the one we encourage, but sometimes we have to use the other in certain circumstances. Now, before I go in and draw my line, the next thing I need to determine is, with linear inequalities, is it a dashed or solid line? And in order to determine that, we look at the inequality symbol. And if there's any portion of an equals to sign, that means it is a solid line. On this one, we have the inequality symbol greater than or equal to, so it does have a portion of an equals to sign, which means when we draw our line, it should be completely solid. So now I'm going to line up the points as best I possibly can, all right? And getting them through the middle here can be really important, so I'm going to draw my line, trying to get right through the middle if possible. And then arrows at each end, making sure it goes all the way across my graph. Now, remembering that with solid lines, any points that fall on the line with these are solutions to the inequalities. So my next step that I want to do is I want to choose a test point. Now, my normal test point of 0, 0 falls on this line, so I can't use it. I have to have it on one side or the other. So I'm going to choose the point 1, 1. All All right, so that's right here. It's just barely below the line on that side, right? And that's okay. It doesn't have to be way away from the line. If you'd prefer it was, that's fine too. I'm going to use the test point of 1, 1. So I'm going to write that out. Here's my test point 1, 1. And I need to plug that stuff into the appropriate places, remembering that this is x and this is y. But if I use a double number 1 again, remember that'll make it easier because I can't accidentally plug y in for x or vice versa. They're the same number. So into the inequality for y goes 1. So we have 1 is greater than or equal to 3 halves times 1. Then I need to simplify it. Well, 3 halves times 1, anything times 1 is still itself. So this is just 3 halves. And then this side didn't change. So we've got 1 is greater than or equal to 3 halves. Well, I have to remember with 3 halves that that is the same as 1 1/2. So really what I'm saying is 1 is greater than or equal to 1 1/2. Is that true? Well, 1's not greater than 1 1/2, and it's certainly not equal to it, so this is false, which means everything on the side of my test point right here of 1, 1 is going to be false. There's no solutions on that side, which means that everything on the other side is going to be true. And a reminder, we always shade the true side. So I'm going to come in and shade this side, covering the rest of the coordinate plane on that side. So there we go. There's my solution side right there. So then last things we need to do, check each ordered pair to see which ones are solutions. So 0, 6, start at the origin, don't move left or right, but move up 6. So 1, 2, 3, 4, 5, 6. That falls in my shaded region, so it is a solution. Then negative 4, 1, back to the origin, go left 1, 2, 3, 4, up 1. Again, that falls in my shaded region, so that is a solution. Then the point negative 2, negative 7, that says from the origin, go left 1, 2, and down 1, 2, 3, 4, 5, 6, 7. Now that point fell in the non-shaded region, which means that it is not a solution. My next point of 10, negative 3, back to the origin, go right 10 and down 3. Again, that also fell in the non-shaded region, so that is not a solution as well. And then my last point, 4, 6, back to the origin, go right 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. Now this point again fell on the line. So if for it to be a solution, this needs to be a solid line, which it is. So that means the point 4, 6 is a solution to the linear inequality. All right, well, we've got one more example we want to go through. So I would encourage you definitely try this one on your own, then check your answer with mine. So first step on this one, all right, again, as always, start with the y-intercept. So what is my y-intercept? Well, again, it's found after the x, so that would be positive 1, and that's the y-coordinate, so 0, 1. So that's my first point to graph. So start at the origin, don't move left or right, but move up 1. So there is my first point. Then I need the slope, right? And again, slope is always found in front of x. So it's 2. Well, in order to use slope, I need it in a fraction form, so that's really 2 over 1. So 2 over 1. Then I need to know what each number tells me. Well, the top number is always rise or fall, and because this is a positive 2, that tells me to rise 2. And then the bottom number, it's positive, so that tells me to move to the right 1. So now I need to do that. So from my y-intercept, I'm going to rise 1, 2, move to the right 1, and there is my next point. And then again, rise 1, 2, move to the right 1. Now again, just as a friendly reminder, you can always do the opposite of both those things. So instead of rising 2, I can fall 1, 2, and instead of moving to the right 1, I can move to the left 1. And that still should be a point on our line, which it is. Now before I go in and draw my line, always make sure, check the inequality symbol, because we need to decide if it's a dashed or solid line. This inequality symbol is a greater than or equal to. The portion of an equals to sign tells me that this is a solid line. So I'm going to go in and I'm going to draw my line, and it is going to be solid. So again, always trying to line up the points as best possible so I can get right through the middle all the way across the graph, and then I need arrows on each end. Now if you end up with a graph that maybe your line didn't end up perfectly right through the middle, so you may notice my bottom point, it's a little bit to one of the sides, all right? You can always erase and redo, or if you end up with anything right really similar in terms of where it's at in relation to the line, just check and do some quick slopes to see if it is on the line or not. All right, so next thing we need to do is we need to use a test point. Well, we do not go through the point 0, 0, so I'm going to use that as my test point. It is below my line here. So my test point is going to be 0, 0. And I'm going to plug that into my linear inequality. So n for y goes 0, which is greater than or equal to 2 times n for x goes 0 plus 1. So 2 times 0, that's 0, so we know that this cancels, and we're left just with 0 is greater than or equal to positive 1. So then we need to decide, is that true? Is 0 greater than or equal to 1? Well, it's not greater than, and it's definitely not equal to, so this is false, which means everything on the side of the line where the test point was, so below this line, was false, which means everything on the opposite side was true. That's where all the solutions lie, so I'm going to shade the true side. So here we go in, shade my side. I want to make sure it's obvious that this is the solution side. All right, so last steps, we need to check each one point, see if they fall in the solution area, or because this is a solid line on the line. So -1, 0, so that says move right 1, or excuse me, not right 1, left 1 from the origin, and then don't move up or down. That does fall in my shaded region, just barely, so it is a solution. 2, 5, so back to the origin, move right 1, 2, and then up 1, 2, 3, 4, 5. So it falls directly on my line. Because it is directly on my line, I need to decide, is it a solution? The only way it can be is if this is a solid line. It is a solid line, so that means that 2, 5 is a solution. Then I need to check the point 2, 2. So back to the origin, go right 2 and up 2. This falls below the line in the non-shaded region, so it is not a solution. So next point, -3, -6, back to the origin, go left 1, 2, 3, and then down 1, 2, 3, 4, 5, 6. Again, it falls below the line, so in the non-shaded region, so it is not a solution. And so the next thing we need to check, -4, 5. So back to the origin, go left 1, 2, 3, 4, up 1, 2, 3, 4, 5. It falls in the shaded region, so it is a solution. All right, well, if you have any additional questions on determining and identifying solutions to a linear inequality, please let me know. But otherwise, you should have what you need to complete worksheet number 5 in the Chapter 3 worksheet packet.